Okay, so development of pentagonal prism of side 30 mm and length 60 mm using parallel line method. Okay, so how we project, you can see here I have constructed the top and front view of a pentagonal prism, and now we have to construct the development of this. So how we do it means, so we will be extending the lines here just like this little bit. Okay, so we'll be extending the lines. Okay, so here the line, it is same parallel. So I'll be starting from this end, say here, from here a vertical line, that is true length 60. Okay, and here you can see this pentagonal prism having 5 sides. Okay, so what we do, we'll measure 30. So 30 means you can measure from the compass, or you can directly cut it for each 3 boxes. Okay, so total 5 faces we have to get. Okay, so now draw vertical lines. Okay, so 5 faces, you can see 1 2 3 4 5, each of the faces having the same edge length of the pentagonal prism. So we will be giving the naming as in capital letters, that is A1, B1, C1, D1, E1 and A1. Again it is joining with the same face. Okay, same way. So we'll be writing for this top also capital A, B, C, D, E and E. So this is nothing but the development of this pentagonal prism using parallel line method. Sphere prism of base side 35 given. So rest on the base on HP. So with the faces equally inclined to VP. So you can see, so with respect to the diagram given here, we need to draw the development of the lateral surface. So it has been cut with respect to the diagram here. So you can see we have a base edge of 35 and it is a square prism. So 4 sides means, so it is around 140 mm. So the total length we get, it is 140 mm. So first we will take initial edge here. Okay, initial reference point. Okay, from there, okay, so you can see it is having 4 sides and each of the sides are having 35 mm. You can measure from the scale, or you can measure the same length from the top view of the first diagram. Okay, 35 you need to measure and cut 4 arcs. Okay, 4 arcs you have to cut here. Okay, 4 arcs you need to cut. Okay, so we will extend the line here till the cutted arc. So the top side also we do the same thing. Okay, now wherever the cutted arc is there, so we will be drawing vertical lines. Okay, these are the true lengths. Okay, so we need to draw the vertical lines where we have cutted the arc. Okay, so now we have to mention the namings here. Okay, so capital A, capital B, capital C, capital D, and capital A. So at the A, so it exactly cutting at here 1, and at B it is 2 here, and at the 3, so it is cutting exactly here at the C point, and again at D it is 4, it is cutting at D here. Okay, so now we will join all these points 1, 2, 3, 4 with a straight line here. Okay, so the cutted portion, so the remained cutted portion we need to show in the dark line, so that's why I'm using the pen here. So you need to dark this. This is what the development of the cutted portion of the prism. Okay, we need to join the base heads also here. Okay, so this completes the problem. A rectangular prism of base side 25 into 40 mm given, axis length 65. It is resting on HP on its base with the longer side of the base inclined at 30 degree to VP. So it is cut by a plane inclined at 40 degree to HP and perpendicular to VP, and exactly passing at extreme left corner of the base. Okay, so first I will be drawing an XY line. Okay, XY line I will draw now. Okay, I will take a reference point on this. Okay, take reference point. So keep the protractor at this point. Mark for angle 30 degree. Okay, so it is exactly inclined at an angle of 30 degree. Okay, so draw a line of length passing through this angle point. So the angle it is 30 degree. Okay, and here it is placed with the longer side it is 40 mm. So measure the length of 40 mm on this angle line. Okay, angle line 40 mm. So now you take the protractor, mark exactly at 90 degree using these reference points. Okay, again we keep the protractor at the another reference point, mark for 90 degree. Okay, now we draw a line of length passing through this point at a height of 25 mm. It is a rectangular prism. Okay, so draw a line of length passing through this 90 degree point at a height of 25 mm. So 25, so you can mark 25 mm here. Okay, then join. So that completes a rectangle of dimension 40 into 25. So we will show the dimension. So you can show on the upper side or the lower side, no problem. So 40 and 25. 40 by 25 and inclined at 30 degree. Okay, now we have to draw the front view of this. So it is an prism, so it is having top face and bottom face. Top face A, B, C, D, bottom face A1, B1, C1 and T1 not visible. That's why it is in bracket. Now we draw the diagonals to find out the center of the axis. Draw the diagonals. Mention O1, center of the axis. Now draw the projection lines from all these endpoints. Okay, so draw the projection line here. Okay, you can see here the axis length they have mentioned, it is 65. So from the axis, first I will draw an axis length for 65 mm, and then the remaining edges also draw for 65. Okay, from all this we need to draw the vertical edges for dimension 65. Then join, we get the rectangular face in the front view for a prism, right? This is an rectangular prism, height of 65. Okay, so we can show the dimension for the front view. So it is 65. Okay, so now we can see there is an cut plane, there is sectional plane cutting at an angle of 40 degree to HP, and it is perpendicular to VP, passing extreme corner, left corner of the base. You can see extreme left corner we need to consider here. So this is whatever the extreme left corner. Okay, keep at this exact point. Okay, and mark for angle 40 degree. Okay, mark for angle 40 degree. Draw a line. Okay, cut plane here, passing through this angle point. Okay, section plane you need to draw here. Okay, and it is exactly at an angle of 40 degree. Okay, now we need to dark the remaining portion, that is retained cut portion. We need to dark this. Okay, so we need to dark this. Okay, now we need to mark the points here. 1 exactly at A, and B exactly at 2 exactly at B, and 3 exactly at C, and 4 exactly at G. So, and again 5 we get it, and 1 here. So now we draw the development of this cutted remaining portion of the prism. Okay, so first I will extend these lines, because these things are drawn with the true lengths of line. Okay, true lengths of line, these things were drawn. So first I will take a reference vertical edge. Okay, from this vertical edge we need to proceed from A to B. You can see from A to B it is having a length of 25. It is having a length of 25. You can cut the arc, so that is your AB, 25. Next, from, so we'll draw vertical line here, and I will show the division for this. So the division it is at 25 mm. Okay, 25. Next, from B to C we have 40 mm. B to C we have 40. So we'll cut the arc, that is BC. BC it is having 40 mm. Okay, BC we have 40 mm. Again from C to D we have 25. Okay, C to D we have again 25, because this is an rectangular prism, so based on the edge we need to consider the length. Again from D to A, again it is 40. So we can mark the points here, D, and this is A. Now we draw the vertical edges exactly at these BC and D and A points. So drawing the vertical edges. Okay, so now we have to mark this point number 1 at A, and at B we have, so we can measure it from the compass, from the top face or from the bottom face we can measure it, no problem. Okay, you can measure that and cut the arc. Again you can measure that point number 3 on the point D, again the point number 4 on the vertical edge D. Okay, so now we can mark the namings here. So it is 2, 3, 4. So now I have to join all these 1, 2, 3, 4, 5 with the straight line. With the help of scale we'll join this. So we need to join this. So we need to dark this the entire retained remaining portion of the rectangular prism. We need to dark this. Okay, so we have to dark it, because this is what the cutted remained portion. Okay, remained portion, we know that we need to dark it. Okay, so this completes the problem. A square prism of base height 30 mm and axis length 60 is resting on HP on its base with all vertical faces being equal to inclined to VP. That means it is here also we need to construct a square prism of dimension 30 with respect to corner position. Okay, and here in the cutting plane it is inclined at 60 degree perpendicular to VP, and it is passing at a distance of 50 mm from the base. So we need to draw the development of the lower portion of the prism here. So first I have taken a reference point, then I have put the protractor and mark for 45 degree. Now I am drawing a line of length 30 mm passing through that point. Okay, so draw a line of length 30 mm passing through that particular point. So from this end also you can draw. Take the compass and cut the arc for 30 mm. You can measure it any one of the edge. At the reference point, from the reference point you can cut it. Okay, and then join it to get the square with respect to corner position. You can show the dimension on one side, that is 30 mm. Okay, then it is a prism, that means it is having two faces, top face and the bottom face. Okay, here in the thin lines I am trying to get the center of the axis. Okay, show the dimension 30. You can write A1, BB1, CC1 and DD1 and O1. Okay, then draw XY line. Draw the projection lines from all these ends. Okay, draw the projection lines. You can draw the axis line of length 60 mm. 60 mm. So you can draw measure exactly 60 mm, that is 6 centimeter from the scale. You can draw vertical line, that is axis line here. So using the axis line we can draw the front view of this square prism. You can easily draw. Okay, so that completes the front view of the square prism. You get a rectangular face here. Okay, now here you can see, so inclined plane, that is a cutting plane. So we will show the dimension here. The dimension it is 60 mm. So axis length we show that. Okay, now you can see that the vertical plane, that is inclined plane, cutting at an angle of 60 degree, and it is at a height of 50 mm from the base. So from the base we need to consider 50. So mark a point for a 50 mm, that is 5 centimeter. Okay, then take the protractor mark for angle 60 degree here. Okay, mark for angle 60 degree, and then draw a line of line passing through that angle point. So mark the reference point. Till there we can draw a cutting plane here. Okay, exactly at that point you can mark. Okay, so here, so that is our 1.1, and exactly where it is meeting. 2 point, it is exactly at the B, and 3 point. So we need to draw vertically downward line. We don't know exactly where it is cutting, so we need to draw vertically downward line. So it is cutting here exactly at 3, and here we get the 4, and 5 point we are getting exactly at the D point here. So we need to draw the development of this. Okay, I'll show where it is exactly cutting. So it is exactly cutting at 50 mm from the base. You can show that dimension. So now you can extend it. So because it is drawn with the parallel line method, just you draw 2 lines extending from here. Okay, so here it is a 30 mm base length. It is having 4 sides, means we need to extend by till 120 mm. Okay, so first I'll take a reference end here. From this point I'll be marking exactly at 120 mm, that is 12 centimeter. On the both side I'll be marking it. Okay, so now we'll join this. Till here we need to extend. Okay, exactly here till here, so you can join it. So now you can take the compass and cut exactly, measure 30, any one of the edge you can measure, and cut 4 arcs here. Okay, it is having 4 sides, right? You can cut 4 arcs. Okay, so you can cut it exactly 4 arcs. Okay, then draw vertical lines joining at these points. Okay, so these are the true lengths you can draw. Okay, so you can mark A, B, C, D, capital A, B, C, D here. Okay, then so we need to extend this one point. So we extend, so we get it on the point A here. On the line A we getting this here. So we're drawing thin lines. So on the A line we marking 1, 1. Same way we will be extending this 2 and 5 point. So if we extend this, so 2 we are getting on the line, that is the edge B, and the 5 point we getting on the edge D. Now for that 3 and 4 we need to measure exactly how much it is. So it is around 1.1 something it is getting. This is 11 mm are getting. So what we do, so we can take the compass and measure the same length, and we can cut the arc. Okay, from 2 to 3 and 5 to 4, like that we can do. So we can measure anyone from here to here or from this point. Okay, so here from here also you can measure. It is around 12-13 mm we are getting it. So we can measure this. So we can measure this, and we can cut the arc by measuring the using compass. So you can measure that particular length, and we can cut the arc here. Okay, from 2 to 3, again from that 5 to 4. Okay, it's the same length it is. You can cut it, and we can mark that is 3 and that is 4. Okay, now we can join all these points. So again I'll draw here one other vertical line here. Okay, so I'll be joining all these things with the straight line. So you need to dark this where we are getting the points, right? Exactly at these points we need to dark this. Okay, we need to dark this. So we need to join with the straight line using scale. Okay, I have to dark these particular points. Okay, need to darken all the edges. Okay, so that is what the development of the lower portion of the prism. Okay, cutted portion. So I'll be darkening this again, these vertical edges. Okay, vertical edges I am darkening here. Okay, here also this cutted portion. So in the front view also I am going to dark it. Okay, that is what the retained portion, cutted portion, retained, and this is what the lower portion of the prism. So that's why we are darkening it. Okay, so that completes the development of the square prism. Okay, thank you. A regular pentagonal prism of height 60 mm and base head 30 mm given, rests on HP. A vertical face close to VP inclined at 30 degree to VP. So draw the development of truncated prism with its truncated surface inclined at 60 degree to its axis and bisecting it. Bisecting means exactly middle point we need to consider. Okay, so first I am going to draw an XY line, writing VPHP and Y. So here we need to construct a pentagon by considering a 30 degree angle line. With respect to that 30 degree angle line, so we need to place that our pentagonal prism. So take a reference point and mark for 30 degree and draw an angle line. Okay, so mention angle 30 degree. Okay, so here with respect to VP, close to VP and inclined at 30 degree. So now edge 30 mm we have to consider. So take 30 mm from the reference point. So take protractor and mark for 72 degree. We know that as external angle of pentagon it is 72 degree it is. So draw a line of length 30 mm passing through that angle point. Same way we have to do it for this side also. Keep the protractor in such a way that and mark for 72 degree and draw a line of length 30 mm passing through that point, because here pentagonal prism having a dimension of 30. Okay, so now take the protractor and cut the arc of 30 mm. So cut the arc. So we have constructed a pentagon here. So you can show the dimension on one side, dimension of 30 mm. So you can mention the naming because it is a prism having both faces, top face and the bottom face. So we can mention the naming here. Okay. So A1, top face A, B, C, D, top face, bottom face E1, B1, C1, D1 and E1. So that is not visible from the top face. So now we have to find out the center of the axis. So to find out the center of the axis in the prism, so we need to draw the perpendicular bisectors here. Perpendicular bisectors. So exactly passing the middle point. So from all these corners, so we need to draw perpendicular bisectors. So perpendicular bisectors will be drawn exactly from corner to the opposite middle point, opposite edge middle point we need to draw. Okay, we get center of the axis of this pentagonal prism. So now we will project it upward. Okay, to complete the front view of this. So draw the projection lines. Okay, from all the ends you can draw the projection lines. Okay, here line of length that is 65 mm. So we can 60 mm it is, sorry. So draw an axis for 60 mm. So all the edges will be having the same length of 60. Okay. So you can mention the namings for the top face and bottom face. You can see here exactly in axis point I think missed. So axis line we get it here. Okay, that is your edge point E1 dash. So we will dark that. Okay, now we are getting exactly O1 dash and O dash. Okay, now from the now we can show the dimension of 60 mm. You can show here. Now we have to consider the angle of inclination 60 degree. Exactly bisecting means exactly half, middle point of the axis we have to consider, middle of the axis. Middle point means if it is 60 means we should consider 30 mm. We should consider exactly 30 mm. Okay, so you can show the dimension here. So now here in this question, the axis will be having inclination of 60 degree, that is truncated surface. That is, from that axis we need to consider an angle of 60 degree. Okay, so this here it is a tricky question. Okay, from that axis point, truncated surface, we need to consider an angle of 60. Okay, so little bit different. So we can show the angle, you can show from the axis to the truncated surface. That's what the angle here. So you can mention the naming now. So where the section plane is cutting it. Okay, 1 2 3 4 you can mark it. So with respect to these points, we need to draw the development of the truncated prism here. Okay, so you can just measure the length from the top surface. So 1 1 we can cut it on A, then 1 2. So from that is the length 2 from the B we need to cut, and the length of 3 we need to cut it on C. Okay, length of 4 we need to cut it on D, and length of 5 we need to cut it on E. So with the help of a compass we can measure the length and cutting the reference points. So we can mention the naming 1 2 3 4 5 and 1. So now you can join all these points with the help of a scale using straight line. Okay, dark the truncated cut portion, the remain cut portion, we should dark it. Okay, so that completes the problem. We have a rectangular prism which is having a base of 14 to 25 and height 65 mm. So rest on HP on its base with the longer side, and it is inclined at 30 degree to VP. So first we draw an XY line and have taken a reference point. So keeping the protractor at that reference point, okay, marking at 30 degree. So you can see 30 degree to VP. So it is an rectangular prism we need to construct, and it is placing with the longer side. Longer side we have it, that is 40. So mark for 30 degree, okay, angle, and draw a line of length passing through this 30 degree angle point. Okay, and show the angle 30 degree. Okay, now on this longer side we need to consider 40 mm. To take reference point of 40, okay, measure 40 using scale 40 mm. Okay, so take a protractor and mark at this at this reference point, mark for 90 degree, exactly perpendicular, mark for 90 degree. Okay, again the another reference point also you keep the protractor and mark for 90 degree. Okay, draw two perpendicular lines here passing through that point, but it has to be have a length of 40 mm. Okay, 40 mm is 4 centimeter from the scale, and sorry, it is 25. So 25 mm you have to draw. Okay, so now join it. So it is 40 by 25 rectangle. Okay, show the dimensions. So dimension 40 mm. Okay, here we have 25. Okay, length of 25 it is. Okay, now we'll be marking the namings for top face and bottom face. A, B, C, D it is for the top face. E1, B1, C1, D1 for the bottom face. Bottom face not visible, that's why it is in bracket. Now we draw the diagonals to find out the center of the axis of this rectangular prism. Okay, that is O01. Okay, now we'll project the projection lines to draw the front view. So draw the projection lines here. From all these points we need to draw the projection lines here. Okay, so now on the axis we have to show the length of 65 from the axis. So that is height of 60. So draw an axis line here. Okay, and the remaining edges also we will construct it for 65. Okay, then join it. So you can show the dimension. So dimension of 65, that is axis height. So you can say it is cut by a section plane at an angle of 40 degree to HP, and it is exactly occurring at the midpoint of the axis height. So we have the axis height of 65. So exactly middle point means 32.5. So we need to mark on the axis line here. We need to mark for 32.5 here. Exactly, we need to mark for 32.5 at the midpoint of the axis. Midpoint it is exactly 32.5, half of the axis. Okay, so we'll show the dimension. Okay, so that is 32.5. Okay, now we have to take the protractor and mark for an angle 40 degree at this reference point. Okay, mark for angle 40 degree and draw an angle line passing through this point. So here we will be constructing a section plane. Okay, we'll extend the same thing. So we can show the angle here first. So angle it is 40 degree. So we'll extend this section plane for the downward side. Okay, now we need to dark the cutted remaining portion, which is cut by the section plane. The remaining portion of the rectangular prism we need to dark this. Okay, and now we need to mark the numbers here for the cutted plane. 1 it is occurring at A, and 2 it is occurring at again B. So C it is occurring at again at 3 it is occurring at, sorry, that's not correct. So it is occurring at point C, 3 point, cutting at C, and D it is occurring at 4 it is occurring at D, and then 5 we have. So now we will draw the development of this by extending the line. Okay, so here it is, we have 40 into 25, correct? 40 into 25. So first we will extend these lines, then using the compass we will cut each of these lengths. Okay, first I'll be cutting for 25, then I'll be cutting for 40, again 25, then again 40. So that's how we will cut the arc on that extended lines. So first I'm going to extend the lines here. So this is what our rectangle prism dimension. Okay, I'm extending the lines here. Okay, So first I will take the reference line. From here we will consider that is A. Okay, from A to B it is 25. We'll take compass, measure 25 mm from A to B. Okay, we'll measure this length from A to B. AB 25 it is. Again from B to C it is 40 mm. From B to C it is 40. Again C to D it is again 25. So you can measure either from the diagram or from that development surface. Again it is 40. D to A. So D to A again 40 it is. You can measure it from B to C only. That is also 40. Okay. So that is our A point. So now we will draw vertical lines connecting at this B point, B, C, D, A. Okay. We extend the lines here. Okay. We need to draw here. Exactly. Okay, after this, so we need to mark the naming here. 1, where it is the 1 it is occurring. Again, either you can measure from the top face or the bottom face. I am measuring from the top face. So the point number 1 here on A, and similarly point number 2 on the B. Okay, and point number 3 on vertical edge C. Okay, and point number 4 on the vertical edge D. Okay, again you can measure that point 1. So point 1 we have again it is on the 1, so it is nothing but 5 or 1 you can mention, no problem in that. So that is our 5. So now we have to join these points with a straight line with the help of the scale. So we have to join it. So join it all these points with a straight line with the help of the scale. To join all these points. And we need to dark this remaining portion of the prism. We need to dark this. So we have to dark it. Okay. So the remaining portion it has to be darker one. Okay, that completes the problem. In this problem they have given cube of side 40, and it is resting on the HP plane with its base such that it is placed such that its vertical face is inclined at 30 degree to VP. Okay, and it is cut by a section plane perpendicular to VP inclined to HP at an angle of 45 degree, and it is exactly passing at middle point of the axis. Okay, so first we'll draw an XY line here. Okay, then from that XY line I will take a reference point. Okay, and draw 30 degree angle line with respect to VP. So take a reference point, keep the protractor and mark for angle 30 degree. Okay, mark for angle 30 degree and draw a line passing through that angle point. Okay, so mention angle 30 degree here. Okay, so we need to draw a cube of side 40. So cube of side 40 we have to draw here. So exactly at 40 mm we need to draw here. So 40 you have to mark. Okay, so it is so these edges were exactly vertical. So I'll be keeping the protractor at these reference points and marking at 90 degree. Okay, marking at 90 degree because we need to draw a square. Okay, all the edges were exactly perpendicular. Again I am keeping the protractor at another reference point and marking at 90 degree. Okay, now you draw a line of length. Okay, draw a line of length Okay, after marking 90 degree, draw a line of length 40 mm passing through this 90 degree point. Okay, so vertical line you have to draw. Just draw a line of length 40 mm. Okay, here also, so you can draw a line of length 40 mm here. Okay, now we can join to complete the sketch. Okay, so you can show the angle. So the angle here we have taken 30 degree, right? So 30 degree we have taken, and you can show the dimension on one side. So the one side dimension will be 40 here. Okay, so we need to find the center of the axis. So draw the lines passing through like diagonals we need to draw to find out the center of the axis. Okay, mention the naming. So cube is also one of the prism, so it is having both top face and bottom face. Top face notations are A, B, C, D. Bottom face notations are A1, B1, D1 within brackets. Okay, so now we have to project it to complete the front view. So draw the projection lines. Okay, so from the axis also we need to draw exactly vertical line. From all the edges we need to draw the projection lines here. Okay, here the axis length also 40 because it is in cube. Okay, it is in cube. Okay, it is also 40 mm. So first we'll draw axis line 40, then remaining edges also we draw it for 40 mm. Okay, okay, that completes the front view. Okay, so we can show the dimension. So dimension here it is 40 mm, 40. Okay, now we have to show an section plane, cut section plane. So it is exactly 45 degree and it is occurring exactly middle point of the axis. So the total axis is 40. So half exactly middle point means we need to mark at 20 on the axis, and then show the dimension 20 mm. Okay, show the dimension 20 mm. Okay, then take the protractor, marking at the reference point, mark for an angle 45 degree. Okay, now draw a straight line, that is cut plane, to that marked angle point. Okay, section plane we need to show where it is cutting exactly. Okay, so angle it is 45 degree. Okay, so now the cutted portion, the remaining cutted portion we will dark it. Okay, we will dark it. Okay, this is what the retained portion after cut by the section plane. So that's why we need to dark this one. Okay, show the axis line here or the section line which is cutting that, dark that one also. And now we will write the naming here. So one exactly cutting, we need to draw vertical line. So on the AB line it is touching it, where it is touching on the AB line. Okay, we need to extend this on the AB line. Okay, AB edge it is touching. Okay, same way. Okay, so we mark for 1 on the top view, same way. So we need to mark for 0.2. So 0.2 here we getting, again we extend it, we write 2. Same way we need to write for 3 here, So 3 here cutting on the BC. Okay, so that is the point 3, and then we have the point 4. Point 4 we getting here, and then point 5 we getting on the D only. Okay, so we write here also D. Okay, so marking of the points, so we have done. So now we have to draw the development of this. So extend the lines. So 40 mm into 4 sides means it is 160 mm total length we have to consider. First I will take a reference edge. Okay, from here exactly 160 mm we need to extend. Okay, the scale we have for 150 mm, so I will be extending by another 10 mm. Okay, so another 10 mm it will be extended. Okay, the same way we do it for the top face also. Top edge extend for total length we need to consider exactly 160. So again I will mark for 150, extend by 10. Okay, now we have to cut the arcs for 40 mm. 4 arcs we have to cut. You can see, so total length of 40 we have to consider 4 arcs. 160 means 4 times you need to cut arc. First arc, second arc, third arc, and fourth one. Okay, now we have to draw the vertical lines where these arcs were cutted. Okay, now we need to mark A, B, C, D, A. Okay, now we have to mark this point 1 here. So 1 it is there exactly at a distance. We need to measure from the top view. You can see there from A to 1 we need to measure from the compass. A to 1 can measure and cut the arc. This is point 1. Okay, and now you can see that, so 2 it is there, so 2 we can measure it from the front view itself. So 1 to 2, so 1 to 2 on exactly on the B. So this is okay. And then point C we need point 3 we need to mention. So from C to 3 we need to measure. Okay, C to 3 you can measure that. So this is point 3. Again we need to measure point number 4. Again I will measure from C to 4. Okay, C to 4 I will measure. C to 4. Okay, point 5 will be there exactly on the D. So I will measure from the top, from the front view, that length, and I am going to cut the arc, that is 0.5. Again 1 we need to measure. So 1 again I will be measuring from again A to here it is measured. Okay, whatever the length it is, mention again 1. Okay, now we need to join using scale with the help of straight line. So we can join it from 1 to 2 straight line, again from 2 to 3. Okay, actually that 3 and 4 point I need to mark on the top line. Okay, top line I am going to mark it. Okay, the point number 3 and 4 I need to mark it at the top end. Okay, so I'll be marking that. because it is exactly cutting at the top face. At the top face it is cutting. So you can see that we need to just draw a vertical line at the point 3. So that is 3, and this is point number 4. So now we'll join it with the straight line. Okay. So then complete that whole diagram, that cutted remaining portion we need to dark it. Okay, we need to dark the vertical edges also, that is retained cutted portion, we need to dark it. Okay, so that's completes the problem. You can see in this regular triangular prism of dimension resting with respect to face parallel to VP near to it, cut as shown in figure. Draw the development of the retained portion of the prism which are shown in figure. So this is what it is given in the question. Triangular prism of dimension 40, axis length 60. So it is cut as it is shown in figure. You can see the numbers here, how it is cutted and marked here. Okay, now we need to draw the development of this. This is the problem number 1 in the solution book. Okay, that point is A. Okay, so here it is a triangular prism, so it is having a dimension of 40. Okay, so it is having 3 sides, means 40 into 3 means 120. So 3 arcs I need to cut. So I can mention B, C and D and A. Okay. So it is done with the parallel line method. That is 1, and 2 we are getting at a height at a length of 18 mm. So we can measure from the top view. Okay, so you can see that the 2 we should get it above here. You can see on the front view we should mention that 2 exactly where it is there in the front view, 2 dash. So there we need to mention. Okay, this is where we need to mention this point number 2. Then 3 we get it here. Again 4 you can see that we need to measure that 3 to 4 length from the top view. So we should measure that and cut the arc here. Okay, and then so here 5 will be having here, and then again 6, 5 to 6 we need to measure from the top view. Okay, that is 6, and 7 we have it here downward. First I'll mark on the upside. The same thing I'll copy downside. Okay. First I'll be drawing the vertical lines here where we have marked 2, 4 and 6. We draw vertical lines, parallel edges. Okay. Now from here 6 to 7 we can mark. Okay, so next we have 7 to 8. So 7 to 8 also we can measure, but 8 it is there on the above. Yes, there it is. So you can measure it, 7 to 8. Okay, now we draw the vertical lines here. That is your 1. Now we'll join all these things with the straight line with the help of scale. Okay. So now we can join all this with the straight line from 1 to 2. Okay, I'll be drawing thick line using pen. Okay, 1 to 2 and 2 to 3. Okay, 3 to 4 and 4 to 5, 5 to 6, 6 to 7, 7 to 8 and 8 to 1. Okay, and we need to dark this wherever the numbers we have written, right? So from there we will be darking it. So that's what the retained portion of this triangular prism. Okay, so we should dark those vertical lines where we have mentioned these numbers. Okay. This is what the retained portion. So we can mention the overall length here. So the overall length it is 120 mm. Okay. Okay, from A to B it is 40 mm. Okay. Okay, so this completes the problem here. Hexagonal prism of base side 20 mm and height 50 mm. So resting on HP on its base such that one of its edges parallel to VP. Okay, the prism is cut in this position as shown in the following front view. So we have drawn and it is given in the question. So it has been cutted like this. Now we need to draw the development of this lateral surface of the prism. Okay, so I will extend these lines. Okay, we'll draw an reference vertical edge. Okay, so here the hexagonal prism of dimension 20. So 20 into 6 sides means it total 120 mm. So that means if we cut the arc by considering 20 mm means total 6 arcs we have to cut here. Okay, measure 20 mm, and cut 6 arc. Okay. Now you draw vertical lines for these all cutted arc points. Okay. Cutted the vertical lines. where we have cutted the arc points, right? We need to draw the vertical lines here. Okay. So now we can mention capital A, B, C, D, E, F, E, A. Okay. For the top face also we write A1, B1, C1, D1, E1, F1 and A1. Okay. So I'll mention it. So that is F1 and A1. We just correct it. Now here you can see already we have marked the point 1, 2, 3, 4, 5. For the top face it is 1. We need to measure from top face 1. We need to mark. Then again for 2 we cut it on the vertical edge B, and for the point C, point number 3, we need to cut it on the point C here, vertical edge C. Now on the point 4 it is here exactly at the end point of D1. So you can mention 1, 2, 3, 4. For the 5 again we need to measure, so that is exactly equal to 3. We already measured, that's why we cutting the same length. Then for the point 6, for F1, okay, and then exactly 1 we need to cut at the vertical edge A here. Okay, that is 1. Sorry, that is 1. Now again we need measure for the bottom face. Okay, on the vertical edge B it is 7. Now we need to measure for 8 on the vertical edge C. Okay, measure a length from C1 to 8 and it has to be cut on the C. Okay, we need to cut it on the vertical edge C here. We need to cut it on the vertical edge C here, that is point number 8. Then 9 we need to cut it on the vertical edge D. Okay, and then 10. Okay, and then again 11. Okay, so that is 8, 9, 10, 11. So now we have to join all these points with the straight line with the help of the scale here. We have to join it. That is after 6, that is 1. You can correct that. Okay, that is 1. So now you have to join it from A here. Okay, A to 7, A to 7, 7 to 8, like that we need to join. Nine to 10, then 10 to 11, and then 11 to A we need to join. Now to dark these vertical edges. This is what the retained cut portion, okay, of that hexagonal prism. So we have to dark this. Okay, so that completes the problem. Okay, now we will develop a pentagonal pyramid of side 30 mm and axis length 50. So using radial line method. Okay, so we are going to develop that. So how we are going to develop, you can see in this problem I have already drawn the top and front view of a pentagonal pyramid. Okay, you can see here, so this is the true length, that is this length, that is O dash D dash. Because why it is true length means, you can see the end OD, it is parallel to this XY line. Okay, so parallel to this OD XY line, that's why this O dash D dash is the true length. So what we have to do in this problem is, first I will take one reference point here. Okay, here. Then after that I'll be measuring this length, that is O dash true length I will consider, because we know the development of any of the solids we have to do with the true length. Okay, so I'm going to construct this, cut the arc. Okay, this is what the length, right? So that is 0.5. Okay, so 0.5 from here to here. This is the length, true length. Now after that, what we have to do, so using compass, we'll be measuring this length. Okay, and then we'll be drawing a small thin line. Okay, small thin line. Okay, like this. Then after that, as we know that, so this each of these edges were 30 mm, so we'll be measuring 30. So any one of the edge you can measure, so that is 30. From here you can cut it for 5 points. So we can extend this, no problem. Okay, so 1 2 3 4, another line, so total 5 faces. We can extend it. Okay, so 1 2 3 4 5, so totally 5 faces we get it here. So after this, what we have to do is we have to join these points. Okay. Okay, so you can see we have 5 faces because it is in pentagonal pyramid, 1 2 3 4 5. So after this, what you have to do is we have to connect these end points with the straight line. Okay, like this, because it is a pyramid. Okay, and then rub this curve, okay, which we have drawn in the beginning. So we have to rub it. Okay, now we can give the naming. This is A, this is B, this is C, this is D, this is E, and again E. So this completes the pentagonal pyramid, that is development of pentagonal pyramid using radial line method. Square pyramid of base 40 mm side and axis 60 mm line. Length has its base on HP, and all the edges of the base are equally inclined to VP, means we need to construct with the corner position here. So it is cut by an inclined section plane, so that the truncated surface at 45 degree to the axis. By bisecting it, draw the development of the truncated pyramid. So bisecting it means exactly middle of the axis it is cutting, that is 45 degree section plane on the axis. So first we draw an XY line here. Okay, so we will be constructing a square with respect to corner position here. So for that I'll be taking a protractor. First I will take a reference point. Okay, so from that reference point I'll be marking at 45 degree on both sides. We'll be marking 45 degree on both sides. Okay, then I'll be drawing a line of length 40 mm here, passing through that angle point on the both side. Then after that I'll be drawing a line of length 40 mm, so passing through that 45 degree angle point. Okay, then I will take a compass, measure 40 mm, any one of the length we can measure it, and we can cut the arc. So 2 arcs we can easily cut here. Okay. So then join using scale here. And you can show the dimension on one side. Okay, the dimension here it is 40 mm. Okay, you can mention the naming ABCD. It is having only one base ABCD. So connected with the vertex by means of slant edges here. So I'll be drawing slant edges. So these inside lines has to be thick lines. Okay, thick lines O1. Okay, now you project it upward to complete the front view. So here the axis length we should consider, that is 65 mm. Okay, 65 mm long. Okay, so exactly from that corner point we need to join here. So exactly to that axis end point we need to join. Okay, so it is of length, axis length 65. We can show that. Okay, now we have to show the inclined section plane, that is exactly cutting, bisecting it means exactly cutting at the middle point here. So you can see that. So it is making as a truncated surface. Bisecting it means exactly middle, it is cutting the axis. So 65 means 32.5 we have to mark. 32.5 we can mark, and we can show the dimension here. Okay, .5. Okay, and we can show the angle. So the angle here we consider 45 degree. So draw a line passing through that point. Okay, here we are drawing that section plane. So cutting, so I can mention the angle it is 45 degree. Okay, so we need to dark the retained cut portion of the pyramid. So it is forming like a truncated surface. Truncated means cutted portion. So here we have left out with the cutted portion. The truncated surface we need to dark, okay, which is cut by that section plane. Okay, now we have to mark the numbers here by cutting the section plane. So one, it is when we project downward, it is cutting on the slant edge OA. So that is our point number 1. Okay, so it is a slanted surface, that's why we need to do like this only. And then for the point number 2 we getting here, okay, on the slant edge B, and then we have next point 3 and point 4. So point 3 we can get it easily just by projecting downward. We get it on the slant edge OC. Okay, that is our point C. Okay, but for point 2 and 4 we are not getting on the exact slant edges. So for that we will be drawing a line from this 2 and 4 to this slant edge. Okay, slant edge we are drawing it, and then projecting downward from that point. Vertically downward we need to project it downward. Okay, so this is the distance we got. So after getting this distance we have to take compass, measure the distance and draw an arc or a circle, you can say that. Okay, draw an arc on the slant edges of OD and OB. So I will be drawing like an half circle. So that particular arc is cutting OD and OB slant edge. So here we get the point number 2 and point number 4. This is where it is cutting. Now from the top view, so we can show how it has been cutted with that section plane. So now we are getting the truncated portion. You can see that clearly from the top view. So we need to join this 1 2 3 4 with the straight line using scale. Okay, so that's what the top and front view. Now we need to draw the development of this truncated pyramid. Okay, first we need to identify the true length. So here the true length, it is, you can see from the top view OC it is parallel to XY. That's why O dash C dash is our true length of line. Okay, we need to measure how much it is length. I'll show with the dimension here. So if you just measure the length, it is around 70 mm. So you can measure that and write down there. Okay. Okay, now for this 70 mm true length, we need to construct. So take a reference point, anywhere you can take. So first, so this is nothing but our true length. So we need to draw for the true length. Okay. So that's why we consider O dash C dash here, not the axis length. So we'll be drawing for 70 mm now. That's what the true length. One line I will draw. Okay, then I will take the compass. So measuring for 70 mm, measuring for 70 mm. So that particular, and then I will be drawing an arc here, or a semicircle, you can say that. Okay. So here after drawing this semicircle, so we need to cut it. So we need to cut it for exactly 40 mm because the base edge it is 40, and we need to cut, it is a square pyramid, so we need to cut off 40 length for 4 arcs here, 1 2 3 and 4. So totally 4 arcs we have to cut it here. Okay, so now we can join using scale, we can join it. So these are nothing but your slant edges and the true lengths. Okay, OB, OA, OC and OD. These are nothing but your slant edges. There are totally 4 slant edges we are getting here. Okay, so you can join this with the straight line here also, because it is a square pyramid. All the edges were straight here. Okay. Okay, after completing it, so we will erase this semicircle which we have been drawn, okay, as a reference to construct this truncated pyramid. So we will erase it. Okay. So now we can mark the naming now. So this is A, B, C, D and A. Okay, that is O. So we need to mark the length. Okay, this is what our true length, we have been drawn for the true length here. Okay, now we have to consider that O1, that is O to 1, O dash and 1. So I will consider all this 1 2 3 4 on that true length, O dash C dash. Okay, I will consider that length, but just drawing that one a horizontal line from that 1 to till it touches the C dash, O dash C dash. Now I will measure the length using compass from O dash to 1. Okay, cut the arc, and then O1 on OA will get 1 1 only. So that's why I have cut 2 arcs. Then O2, that also we need to consider on the true length only. Okay, not on the axis. Just see that already we have drawn a straight line from the point number 2 of 2 and 4 on the true length. So that length I am considering, not on the axis. So this is very important. And then again you can consider it from O to 3, that is already there on that true length. Now we can write 1 2 3 4 and again 1. Okay, So you can join using straight line with the scale. You can join this. Okay, so now you can dark that truncated remaining portion. So we have to dark this. So dark the truncated pyramid, so the left out portion. Okay, we need to dark this. Okay, those slant edges also we need to dark in the truncated portion. Okay, so that completes the problem. Welcome to engineering visualization channel. So now today problem number 18. The square pyramid of base height 45, altitude 70 mm is resting with its base on HP with the two sides of the base parallel to VP. So first we are going to construct the square pyramid of base height 45 mm and altitude. Altitude means it is nothing but height, height of the axis. Okay, it is 70 mm, height of the axis 70 mm, resting on HP with two sides of the base parallel to the VP here. Okay, first I am going to construct an XY line. Drawing XY line. And write VPHP, that is your first quadrant, and construct a square here. So the base parallel to the VP. So dimension here it is 45 mm, exactly at 90 degree we can do it. Construct the square and give the naming ABCD and show the dimension of it. Okay, so the dimension of the square pyramid it is 45 mm. So here it is parallel to VP, that's how we have drawn. You can see that edge DC and AB are parallel. AD and BC are parallel to VP. You can see all the edges here are parallel only, that is AB and DC. Now draw the slant edges. Since it is a pyramid, we should draw the darker line here, that is thick lines we should draw since it is a pyramid. So in pyramid we should draw the thick lines. Okay, inside lines should be darker lines here, or thick lines should be drawn. So connect from B to D and A to C and mention O1. Okay, now project it upward to draw the front view. So in the front view we have to consider the altitude. Altitude nothing but the height. So here it is height of 70 mm. So draw the front view. So front view of a pyramid, it is a triangle. Okay. So here the height, it is 70 mm. You can show the dimension. Okay, now we have to show the cut plane. The pyramid, it is cut by a section plane which is perpendicular to VP and inclined at 40 degree to the HP. Okay, and this cutting plane is bisect the axis. Bisect the axis means exactly we have to consider the midpoint. So bisect means it is nothing but midpoint. So midpoint of the axis here, the axis length is 70. So exactly half midpoint means it is 35 mm. So mark at the midpoint. Okay, show the dimension here. The midpoint height, it is 35 mm. And we have to draw an angle line for 40 degree. And we need to extend that because it is exactly cutting at 40 degree angle. Okay, I'll be showing the angle there. Hit on the like button, subscribe to my channel, share it to maximum students so that they can be benefited. Can write the cut points now. 1, 2, 3, 4. One cut point is cutting at a slant edge of EO, 2 it as BO, 3 at CO, and 4 at DO. Okay. Now you see here, none of the slant edges here are not parallel to the XY line. So we have to make parallel here. Okay. None of the edges, either you can see AO or BO or CO or DO, none of the slant edges here are not parallel to the XY line or parallel to the VP plane. So what we have to make, we have to take any one of the slant edges and we have to make it parallel to this XY line. So take the compass. First I will draw one horizontal line and measure the length of BO, that is slant edge BO. I am making that BO slant edge parallel to XY. Measure the length and cut an arc. Okay. So now making it parallel to the XY line. Okay. Parallel to the VPR, you can say that. Now project upward till the XY line. Now from that XY point of intersection, join to the apex here. So this is what your slant edge length. Okay. Now measure the length. How much you are getting it? Measure it. It is 77 mm. So that is what your slant edge length. Okay, first I will be drawing that slant edge length. Okay, that is 77 mm. Show the dimension. That is OA. Now measure this length using compass and draw an arc here. Now we have to cut the arc points with the dimension of 45 mm. Here it is a square pyramid, that means total 4 arcs we have to cut from the reference point of A. One arc, second arc, third and fourth. Okay, and you can write down this as B, C, D and A. Now join all these cut points, join to the reference point A, O here. Draw a straight line from where you have cutted and marked. Okay, subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. Now draw the base edge. So base edge here it is 40. So connect all this with a straight line. So you can show the dimension for one base edge, that is 45 mm. Okay. Now I am transferring all this point number 1 and 1, 2, 3 and 4 on the slant edge length. Okay. So from the exactly cut point, draw the line. The cut point, that is 2, 3, this is 1 and 4. Okay. Now take the compass, measure the length. 1 and 4 having the same length, so that's why I'll measure only one length here and cut arc on OA, OD and again OA. Okay. That is your 1 and that is 1 and 4. Now 2 and 3. 2 and 3 are on the same point. We'll measure the one length here and cut it on OB and OC. It is 2 and 3. Now we have to connect all this 1, 2, 3, 4 with a straight line. Okay, now we have to dark this lower cut portion. Okay, I'm going to dark it. Hit on the like button and subscribe to my channel and hit on the bell icon for the latest notifications, and share it to maximum students, your classmates, so that they can be benefited from this channel. Thank you all. Thank you for watching the video. Square pyramid of dimension 25 and height 50 mm we have to construct. So rest with its base on HP with all of its edges equally inclined to VP. That means we need to construct with respect to corner here. It is cut by a plane perpendicular to VP, inclined at 60 degree, passing through extreme right corner of the base. Okay, so that's what we have to do. First we need to construct a square with respect to corner, because they have mentioned with all of its edges, base edges equally inclined to VP. That means we need to construct with the corner here. First we draw XY line, VP, HP, first quadrant. So now with the help of the protractor, so I'll be marking a reference point. So from this reference point we can mark for angle 45 degree on both sides. Okay. Now I'll be drawing a line of length at 25 mm. So from that reference point to that angle point. So draw a straight line of length at 25 mm. Okay, so in this side also we need to draw line of length at 25 mm. Okay, so again you take compass, measure 25 mm and cut the respective arc from this reference edges. Okay, then join it with the help of scale, this straight line. Okay, so that completes the square. So it is a square pyramid. So we will be drawing thick lines, inside thick lines as a slant edges. Okay, so mention the dimension on one side. So dimension will be 25 mm. Okay, so 25. So we mention the naming A, B, C, D. Only it has having bottom face, O1, center of the axis. So project upward to complete the front view. So here axis length it is of 50 mm. So draw a vertical line or axis for 50 mm. Okay, now we can join with the slant edges. Okay, show the dimension having 50 mm. Mention the naming A dash, B dash, D dash in bracket and C dash, O1 dash and O dash. Okay, so now we have to mention that cut plane or the section plane. So it is extreme right corner, that is C point is the reference, extreme right corner, and from this point we need to mark for an angle of 60 degree. Okay, 60 degree. Take protractor and mark for 60 degree from C dash and draw an section plane passing through this point. Okay, so here the angle it is 60 degree. Okay. Now dark the retained portion. Okay, the cut portion, the remaining cut portion we need to dark this. Okay, now we will be mentioning the cut plane namings 1, and if we project it downward it is cutting with respect to the OC edge, slant edge 1. Now the point number 2 and point number 3 it is exactly at the C dash only, that is point 3, cutting the extreme edge 3, and point 4 exactly it is at 2 only. So now we have to mention 2 and 4 exactly where it is occurring on the slant edge. So we will be drawing a straight line, that is slant edge for that true length O dash C dash strand length. Then from the 2 and 4 we will be drawing vertically straight line. We don't know exactly where it is cutting. Okay, so we can measure the length from that, then draw an arc or a semicircle to the OD and OB. So we can cut the arc. Okay, so that is our point 2 and 4, and this is point 3. Okay, we can join these points 1 2 3 4. So that indicates that cutted portion, how it is cutting with that okay, section plane. Okay, so now so the true length we having OC, it is exactly parallel to xy line. So O dash C dash is our true length. So we need to measure this length. So it is, so you can see OC is parallel to xy, and O dash C dash length, it is around 52 or 53 mm. It is, I think it is around 52 mm. So dimension, so we can mention that 53 mm. So this is true length. Okay, this is what the length we have to consider to draw the development. So take a reference point and draw a line of length 53 mm. Okay, that's what the true length. And that is O and A. Okay, so this is true length. Now we take compass and measure this length, true length, and we will draw an arc array. Okay, so now we measure the edge here, 25. So 25 is the base edge, and we need to cut 4 arcs here. Okay, 25, 25, 25 and 25. Okay, now we can join with the slant edges. So that is B, C, D and A. Okay, so I can show the dimension. So dimension here we have 53, and that is true length. Okay, so we should not consider the axis for this, we should consider the true length here. Okay, so now you can see, so we have to mark these cutted points 1, 2, 3 and 4. Okay, so we'll be measuring. So taking on the O dash C dash point 1. Okay, O1, so O dash 1. So cut the arc. So we have O, we can cut on the 2 points. Again O2 now. So we have considered this length on the true length. Okay, 2 and 5 having the same length. Okay, 2 and 5. And then O dash and 3. And it is cutting exactly at the 3 point here, at a C point. Okay, that is 1, 2, 3, 4, and this is 1 again. Okay, now we have to join all these, connect this point with the straight line. So now I have to join this. So now we have to dark this retained cut portion. Okay, so we have to join this ABCD also with the straight lines. Okay, now we can dark that retained cut portion. So we need to dark this. Can dark this cutted portion. Okay, the retained portion we need to dark it. Okay, which has been cutted, and then you can erase that arc which have been drawn. Okay, so that completes the problem. Welcome to Engineering Visualization channel. So the next problem, it is a rectangular pyramid of base side 25 into 40 and height 50 mm, has one of its base edges is inclined at 30 degree to VP. Draw the development. So here you can see they will be giving the front view. Using this top and front view, we have to draw the development of it. So in this problem they will be giving everything. So looking at the top and front view, so we have to construct the development here. So first I will be constructing the slant edge length here. So slant edge length 55 mm. Okay, after drawing the slant edge length, okay, you measure the same length using compass and draw an arc. Okay, now we have to show the dimensions for this length. So it is having a length of 55, slant edge length. Okay, now we have to cut according to this rectangular pyramid. So AB length it is 25. I am measuring from the top view and cut the arc. So this is B. Now from B to C, okay, or B to E, it is there from the diagram. B to E it is 12.8. So measuring the same length and marking E here. Now measuring the length of B to C. So B to C measured from the top view, it is 40. Mark C here. Now measure the length CD. Measure the length of CD. CD length it is 25 and cut the arc. Okay. Again measure the length of DA here. So DA length of 40 mm and cut the arc. Okay. Now the another point we have left, that is D to F. Okay. D to F 12.8 again. So cut it. Okay, now we have to join all these points with the reference point here. Use the scale to join all these points. With the help of the scale you can join, connect with the straight line. These are nothing but your slant edge lengths. Connect it. You can see point number 1, 2, 3. So that is on the A line and the B and the E slant edge. It is of same length. Okay. So measuring the same length, so and we can cut it. And point number 2, it is then on our slant edge of B. So it is also of the same length. So measure and cut. In same way, point number 3. Point number 3, it is there on the E here. So measure the same. It is also of the same length. That is 1, 2, 3. Okay. Measure and cut it. Now point number 4. Okay, point number 4, it is lying on the slant edge of C here. Measure that length and cut the arc. Okay, that is your point number 4. And now point number 5. Point number 5, it is falling on a vertical edge of D here. Measure the length and cut the arc. That is your point number 5. And now point number 6. Point number 6 are also having the same length and it is falling on the slant edge of F. Okay. Measure the same length on the slant edge and cut the arc. Okay. And then again point number 1 having the same length. You cut with the same arc length. Okay. Now we have to connect all these 1, 2, 3, 4 with the help of scale. Join all these points here, connect it, connect all these points with the help of the scale. Okay, connect it. Okay. So since it is the development of the lower cut portion, we are going to dark the lower part here. So dark all the slant edges with a thick line. Okay, connect all this lower portion. So join the base heads here. Okay, so now we can mention the dimension here. So from A to B it is 25 mm. Okay, mention the dimension. And from B to C it is 40 mm because it is the development of a rectangular pyramid. 40 mm. Okay, that's complete the problem. You can subscribe to my channel and hit on the bell icon for the latest notification and share it to maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Okay, hexagonal pyramid, dimension 35 and altitude 65 mm, resting on HP on its base, with the two of the base sides perpendicular to VP. And pyramid is cut by a plane inclined at 30 degree to HP and perpendicular to VP, and it is intersecting the axis at a height of 30 mm above the base. So draw the development of the remaining portion of the pyramid. So first we need to construct a hexagon here. So for that I will be constructing first XY line. Okay, XY line, and using circle method I will be constructing a hexagon. So dimension I need to measure, that is 35 mm, that is 3.5 centimeter. Using scale with the help of a compass I will be constructing a circle. Okay, so you can draw a vertical line from that center point. It's like radius. So after that already we have measured 35 mm from the compass. So we need to cut 6 arcs here. Okay, now connect all these arc points with the help of a scale. With straight line you can connect all these arc points. Okay, and show the dimension. So dimension here it is 35 mm. So you can mention the naming A, B, C, D, E, F. Okay, and you can erase that circle, so which we have been used to construct the hexagon. Okay, so since it is a pyramid, so we will be drawing diagonals to show the slant edges. Right, one. So now you draw the front view of this. So the altitude height is 65 mm. So we should consider a length axis height, it is 65 here. Okay. So connect it. Okay, you can mention the naming here. Okay, so show the dimension. So dimension, it is 65 mm. Okay. So, and it is cut by a plane inclined at 30 degree to HP and perpendicular to VP, intersecting the axis at a height of 30 mm from the base. So from the base we should consider a length of 30 mm. So take a reference point. So keep the you can show the dimension for this. Dimension of 30. You can keep the protractor here and mark for angle 30 degree. Okay, so now you can draw an section plane passing through this angle point. Okay, so now we have to give the so naming for it angle 30 degree we can show here. So dark that cutted portion, so which is cut by the section plane, so dark this. Okay, now we can mention the namings here. So mention with the section plane 1, 2, 3, 4, 5, 6. You can see that none of these slant edges are parallel to the XY line. So we need to rotate this OD length. You can see that OD length is not parallel to XY line. So first I will draw an horizontal line. Now I will take a compass OD, measure the length OD and draw an arc. Okay, because none of the edges were parallel here, so we don't get a exact true length, so that's why we have to do like this. So project it upward. Okay, here we get the true length of this hexagonal pyramid. So now join it and show the dimension, measure the dimension, show it how much it is. That is what your true length of this hexagonal pyramid, because none of the edges were not parallel here. So dimension we getting here for true length, it is 73 mm. So that is what true length. So here first you take a reference point. Okay. So now you project all these 1, 2, 3, 4, 5, 6 points on this true length which we have been generated now. So just project the horizontal lines touching the true length. So this is what the length we need to consider when we cutting the arc points. Okay, take a reference point O, measure the length of 73 mm. So draw a straight line 73. Okay. (73). Okay, OA. So take a compass, measure this OA length and draw an arc. Okay, so now we have to cut an arc from that A point 35. Total 6 arcs we have to cut. You can measure any one of the length from the hexagon. So 35, you can cut 6 arcs here. Okay. Okay, now we can join it, this arc point with the straight line. So you can extend a little bit this. Now you join all these cut points with the straight line. Can mention the namings now: B, C, D, E, F and A. So now we have to measure the length using compass. So you can join this ABCD point with the straight line with the help of scale, because this is a hexagonal pyramid. Okay, we need to join this with the straight lines. Okay, now we can cut the arc. So you need to measure from the true lengths. Okay, that should remember, from O to 1, O to 1 and O to 6, these two lengths are same. That's why I'm cutting two arcs. Then again you measure O to 2 and O to 5, these two lengths are same. You can cut the arc on B and F. Okay, then you can cut the arc length, that is 3 and 5. Okay, 3 and 5, sorry, 3 and 4 you can cut. Actually this 6 and 1 are same length, so I think there is mistake. So on the F line, so we need to cut an arc of from O dash to 6. Okay, O dash to 6 we need to measure again, so we need to correct it. So that is the 6, so that is the 5. Okay, now we can mention the namings here, 1 1, and this is 6. Okay, and that is 5, that is 4 3 2. So now we have to join all these 1 2 3 4 with the straight line with the help of scale. You can join it. Okay, so connect all these points, the straight line. Okay, dark all these vertical edges and the cutted portion of the pyramid, we need to dark it. Okay, so that completes the problem. So in the problem, pentagonal pyramid given 30 mm and 50 mm height rests vertically with one of its edges parallel to VP. So we have constructed it is parallel to VP and near to it. You can see it is parallel. It is cut as shown in the following figure. You can see that it has been cutted here. You can see here edge OC, it's not parallel, so we have to rotate and make it parallel here, and then it projected it will get the true length here. We don't have any true length here, so none of the edges in the top view, that is OC, OB, OD, are not parallel here. So we have to make it parallel by rotating OC. Okay, rotating OC, making it parallel, and then project it upward, rotating OC to make it parallel. Here in this problem we have made it parallel, and then projecting it, we are getting the new true length here. Okay, new true length. On the true length we have been projected 1 2 3 4 5. Okay, first take a reference point and construct the true length here. Okay, so here the true length, it is 56 mm. Okay, take compass and draw an curve or the arc. Okay, so measure 30 mm, measure any one of the 30 mm edge and cut 5 arcs here, because it is a pentagonal pyramid, so you can cut 5 arcs. So you can extend that curve. Okay, so total 5 arcs you have to cut because it is in pentagonal pyramid. Okay, now connect with this with the vertical edge. Okay, Join these all these arc points, the straight line, because it is a pyramid. Okay. Now erase that curve. Okay, so you can mention B, C, D, E, and again E. So we need to measure the arc length, the new true length which have been drawn. Okay, new true length 1, 0, 1. So you can cut two arcs here, 0, 1 on OA, and 0, 2. Okay, you can measure it exactly on the true length and the new true length which we have been drawn by rotating the OC line. Okay, that is 1, that is 2. Okay, and 3 we get it on exactly on C point here. Okay, exactly on the C point, extreme corner point. So you can mention that. So that is C, that is 3. Okay, on D we have point number 4. We can measure it using compass, cut the arc, that is 4. And then on 5, so we've been projected this 1, 2, 3, 4 on the new true length which we have been drawn. From there we are measuring the length. Okay, so that's not the slanted, we have drawn the new slanted, that's what your true length. Then you can connect all these points with the straight and with the help of the scale. So join all these. So now we can dark. So this is what the retained upper portion. Okay, you can see that particular portion I am darkening it, so we have to dark it. Okay, development of a cylinder of diameter 50 mm and height 50 mm. So this one will be drawn using parallel line method. Okay, so initially, so we are going to consider here line as a reference. Then I will take a reference point here. So the length of this we should consider, that is pi d, that is circumference of this cone we have to consider, that is we will open up, so it will be a sheet. So pi d, so pi we have diameter is 50, so it is 157. So from this end if I consider, so this is 150, 157 means here extra 7 mm. Okay, so till here, so we can mark. So we need to draw a line till here. Okay, okay, so this total length it is pi d, that is circumference. So this completes the problem. Draw the lateral surface of the cylinder of diameter 40 mm and height 60, which is cut as shown in the figure. So we need to draw the development of this. Okay, we'll extend these lines. So it will be drawn with using parallel line method. So first I will draw an vertical line as a reference from where we will start. Okay, that is our A. Now I'll take a compass, measure this length. Any one of the length you can measure from A, B, or A from B to C. Measure any one of the length and you can cut the arcs. You can mention the namings here. And from H to A also we need to mention. Okay. Now draw vertical lines. Okay, so now you can see that we should mention these namings. Okay, actually the namings will be starting from that C point, not from that A point. Okay, I think that is the mistake there. Okay, so actually the cutting actually occurs from this C point. Okay, 1, 2, and it is occurring only with respect to that C edge. Then 3 on the D, and we have 4 on E, and again 5 on the 6, and then 7. So the 7 we exist on that G point only, so not on H. So you can mention that point number 7 also on that G line only. Okay, so now you can join these things with the vertical line or with the curve. Okay, you can join a vertical cylinder of base diameter 50 and axis length 60 mm is cut by two planes which are perpendicular to VP and inclined at 45 degree to HP, passing through either side of the center point of the top face. Draw the development of the lateral surface of the cylinder. So first we will draw XY line. Here in this problem we need to construct a cylinder here of diameter 50, axis length 60. Okay, so take a compass, measure 25 mm from the scale. Okay, Measure 25 mm from the scale and draw a circle. Okay, now we need to cut this circle into equal parts. Okay, first I'll be drawing a diameter horizontally, then vertically. Okay, now I will take a protractor and mark for angle 30 degree, 30, 60, 90 like that. I will mark 30, 60, 90, 120, 150. Okay, so now with the help of a scale I will be drawing a straight line passing through this angle point on both sides. Okay, so it is totally cut into 12 equal parts, so that means 30 degree. 360 divided by 12 means 30 degree. Okay, here also I will draw a line passing through this angle point. The same way here also I will do. Here also for 150 degree. So I will be drawing a line, angle line. Okay, so now you can give the naming. A, B, C, D, E, F, G, H. So mention the namings. Okay, so you can show the dimension of this circle on one side. So diameter 50. Okay, now we have to project it upward to complete the front view. So front view will be a rectangular face. Front view of a cylinder, it will be a rectangular face. Okay, consider a axis length of 60 here. Can mention the naming in the front view, which are the face visible, that will be written within bracket. So which are the faces not visible, that is written within bracket. Okay, here now we have to draw two planes, so which are perpendicular to VP and inclined at 45 degree to HP. So there are two section planes we have to do. So it is exactly from the center point of the top face. On either side we have to mark at an angle of 45 degree. On either side we have to do it. Okay. So draw now the section planes. Okay, so mention the angle 45 degree. Here also you do the same thing. Okay, and give the naming for the section plane, where it is cutting with respect to the vertical edges. We will mention with the numbers here. Okay, so we'll start from 1 2 3 4 5 6 7 8 9 10 11 12. So we will extend this. So this is also drawn with the true length of line, so parallel edges. parallel line method it is. So we'll extend from the bottom also. Okay. So we can take a first vertical edge from A. We can measure that what we have cutted with respect to 30-degree, right? So we should cut it. So that is A point. So one length you measure and cut the number of arcs, because each of these arc lengths were same. Okay, from AB to BC, BC to CD, all lengths were same here. So you can mention the namings here. At the end also you mention A. Okay, now we draw vertical lines here. Okay, now we have to measure from the compass that points 1, 2, 3, 4 is there, right? We should measure that. So measure all that 1, 2, 3, 4 arc points, okay, from the compass and cut on the respective vertical edges. So again, so 8, 9, 10 points also, and you should measure that and cut the arc on the respective vertical edge. You can mention the naming. So now connect these all these 1, 2, 3, 4 points with a curve here. We need to use curve here to join it. So that completes the problem. A vertical cylinder of base diameter 45 and axis length 60 is cut by a plane perpendicular to VP, inclined at 50 degree to HP, passing through the center point of the top face. So draw the development of the lateral surface of the cylinder. So draw XY line. We need to construct a circle. The diameter given 45. So we need to take radius of 22.5 from the compass and draw a circle. Okay, from the center point, I'll be drawing a radius. Then we can extend this as a diameter. So we will be dividing this circle into 12 equal parts. Okay, so initially I am going to divide into 4 equal parts. Okay, now we use the protractor, keep at the reference point and marking for an angle of 30 degree, 30 degree, 60 degree and 90 degree, like that. Okay, 120 degree and 150. We can draw the lines passing through these points, so we can extend it. And we can mention the naming for this. Project the lines from all these points. Now use the axis length of 60 mm, 60. So now draw a rectangular face here in the front view. It is a cylinder, so that's why we get a rectangular face here. So you can mention the namings. Okay, can mention the naming here. Okay, you can see here exactly at the top face center we need to So you can show the dimension. So dimension of 60. So here axis, we need to draw an section plane of 50 degree exactly from the top face. From the center of the top face, we keep the protractor and mark for angle 50 degree. Okay. Draw a section plane passing through that angle point. Okay. You can extend where it is cutting. You can show that angle here. It is 50 degree. So you can mention the numbers here where it is cutting exactly. Okay. So draw vertical edge. So from here we will mention E. So take the compass again. So measure the length from AB. Any one length you can measure. So we need to cut total 12 arcs here. Now draw vertical lines where we have cutted the arc. So we can extend the line from this 1 2 3 4. That is also one of the way for mentioning. So draw the thin horizontal lines and extend. So 1 we are getting on this vertical line AA. Same way we can do it for the point 2. Okay. Or we can use the compass here for measuring these lengths, so we can cut it easily. Same, we can cut it all the arc lengths here. So mention the naming of these notations. join all these numbers with the help of the scale in straight line. So wherever there is a straight line, we can join it with the help of a scale. Actually it has to be joined with the curve here, so we can join with the straight line here, no problem. And dark this cutted portion, and we need to dark this. Okay, so that completes the problem. Welcome to engineering visualization. Today we see a funnel problem. So here in the question, funnel is made up of sheet metal. The funnel tapers from 60 to 30 mm diameter to a height of 25 mm and then forms to a cylinder with a height of 50 mm. Bottom of the funnel is beveled off completely at an angle of 45 degree to axis. Beveled off means we need to cut it with an angle of 45 degree from one of its corner. So draw the development of the funnel. Okay. So step by step we are going to do. First we are going to construct the top part of it, that is funnel made up of top diameter 60 and the bottom one 30. So tapered section I'm going to do it first. Okay, so mark a length of 60 mm using scale. Okay, now vertically downward the height we should consider, that will be 25 mm. Okay, from the center of the line I'll be drawing vertically straight line downward at a length of 25 mm, that is 2.5 centimeter from the scale. Okay, now from this midpoint, so the bottom part we required that should be 30 mm. So this is exactly 60. From the center we have drawn a line. Okay, from this center we will be drawing 30, means here from the center I will be considering 15 on both sides. Okay, okay, now we join it. So this is the tapered section of the funnel. Now you can show the dimensions. So the top part having 60 mm diameter. Okay guys, this is my 700 video. So I'm very much thankful for my viewers for their continuous support. Okay, so showing dimensions. So the height also I'll show. The height is 25 mm. Now the lower part, it is a cylinder. Okay, cylinder with a height of 50 mm. So funnel it is done. Cylinder of height 50 mm. Okay, can show the dimension for it. It is 50 mm length. Now we need to cut this lower part of the cylinder at an angle of 45 degree. You can see the question. So bottom of the funnel is beveled off completely at an angle of 45 degree two axes. Okay, that is from one end. So we need to draw an angle line, and that should be at an angle of 45 degree. So take the protractor. Okay, mark to the one of its corner end. Yes, we should be marking one of corner end. So mark an angle of 45 degree. Okay, now draw a section line, cutting it. To show it section line, I'll be using different sketch pen. Line dot line. Okay, so it is exactly cutting at an angle of 45 degree. Okay, now we need to construct the top view of this cylinder. Okay, in order to show the cutting, it will become very easy. Okay, so that upper part of the funnel, right? So when we construct, it will not possible, so we will extend it to make it look like an cone. Okay, so construction of the cone, we know using the formula small r by capital R into 360 degree. We can do that. So just I'll extending that. Okay, tapered part, so it will be easy for us when we do the development of it. Okay, so I can measure this dimension, how much it is. So it is around 60 or 62 mm. 62 mm. How much you are getting it, you need to draw for the same length. So in order to understand this problem completely, guys, you need to watch it till the end. Okay, so you can understand all the steps. So now we will be constructing the top view of the cylinder. Okay, because in this problem the cylinder has been beveled. Beveled means cutted, so that means we will be constructing only the top view of the cylinder. Okay, so here the cylinder having a diameter of 30, so I'll be taking compass. The radius will be 15 mm. 15 mm means 1.5 centimeter from the scale. We need to measure. Okay, draw a circle. So we need to project that axis downward, and then we should consider the center. Here I am taking directly the center point of it. So you need to project downward that axis and then take the center point and draw a circle. Okay, so after drawing the circle, so show the dimension. So here we will be cutting this, dividing this circle into 8 equal parts. Okay, diameter 30. So in order to divide into 8 equal parts, we will be using an angle of 45 degree. So using the protractor, we can do it. Okay, so mark angle 45 degree, 90 and 135. Okay, I think the points you are not able to see it properly, so I'll be using the sketch pen so that you can get the exact points. 45 degree here, guys, 45 degree, 90, 135 and 180. After marking it, you can extend, right? Using the scale, we can extend from the center point, merging it and draw the line. Okay, okay, now it is divided, so you can give the naming for these cut parts: A, B, C, D, E, F, G. Okay, now we'll just project it upward so that we can write the top and front view notations. Okay, here I'll differentiate this top and front view. Okay, with XY line, so that we can able to clearly understand it. So top and front view. In this problem, guys, we are starting from the front view and then finishing up the top view. Okay, the problem is like that only. Usually we start from the top view, but in this problem we started from the front view. So draw the projection lines. Now write the namings. So here A dash, B dash, C dash, D dash and E dash visible. H dash, G dash and F dash are not visible. Those are written within brackets. Okay, now we need to write the cut points. Okay, so here so cutting exactly 1, 2, 3, 4. You can see wherever the section plane is cutting, right? So we are writing again here 6 it is, this is 7 and this is 8. Okay, so part by part we are going to do the development of it. Now we have done the cutting also. Okay, step by step we are going to follow it. Okay, this is the funnel and this lower part is the cylinder. So step by step we are going to do it, guys. So watch it till the end, you can understand all the steps. Okay, this is one of the, I can say, the application problem. The first we are doing it is cylinder. Okay, the cut portion cylinder. So here for the cylinder we have the formula pi d. Okay, pi into diameter. Diameter here it is 30. Okay, diameter of the cylinder is 30. So the length what we get, that is 94.24. So this cylinder will be done using parallel method. So I'll be using here two parallel lines, here x from this end and also from this end. Okay, so I'll be considering one vertical line. So the total length we should be considering, that is 94.24. So mark 9.4 here. 9.4. Okay, now we need to divide this 94.24 into 8 equal parts. Okay, the thing can be done by using measuring the compass. You can measure the length from this top view circle. Okay, measure this length and cut the arc. So it will be equally divided. Okay, this is A, B, C, D, E, F, G, H and A again. Okay, use the scale properly, guys. You need to draw straight vertical lines. Okay, okay, now the marking the cut points on this development, it is easy. Just draw horizontal lines from those cutted points. From one, just place the scale like this and just draw horizontal line. Okay, from the point 2 also you do the same thing, and from 3 also the same thing. So this cylinder and prism will be constructed in the same manner, guys, because all the cut points are occurring at these vertical edges. So no need to measure, just draw the projection lines and then now you mark. This is the point number 1 here, and even here on the vertical edge of A, now it is 2. Okay, 2 on the vertical edge B and 8 on the vertical edge H. Same way 3 on C and 7 on G, and then 4 on D and 6 on F, and then 5. Okay, now we need to connect it using the curved line because this is a cylinder. Okay, with the help of color sketch. This is what we need to connect. So using the curve, you need to join. Okay, don't use the scale here. Okay. Okay, so guys, this completes the cylinder. So I'll be showing the dimension. So this is the development part. Okay, development of this beveled cylinder, that is a cutted portion of the cylinder. Now we need to construct the funnel. Okay, funnel, we will be constructing a funnel using this cone method. So for this we have the formula. Okay, funnel, it is resembling the cone. We have the formula small r by capital R into 360 degree to find out the angle of inclination here. Okay, first I'll be finding this slanted edge length. So slanted length, it is 62, and that upper part, okay, upper part which is visible to us, that will be around 22 mm. I think 29 mm it is, sorry. Okay, so capital R, it is 62, that is slanted edge length, and diameter D is 60 mm. So that means R means radius will be 30. Okay, because we need to use this formula in the construction of the funnel, that is small r by capital R into 360. So capital R is your slanted edge length, small r is your radius length. Okay, substituting the values. So and then the angle we need to calculate using the calculator. Here the angle we are getting, it is 174 degree. Okay, so capital R we know it is slanted edge length. So I'll be drawing one horizontal line for a length of using compass, or you can draw a straight line also. So take 62 mm and draw an arc here, curve here. Okay, some semicircle type we need to draw, because here the angle, it is 174 degree, right? So now you can join this. This is having an angle length of 62 mm. You can mark. Okay, so that is your slanted edge length. Capital R. Okay, so the angle we need to mark here, it is 174 degree. Okay, that is our angle. Guys, so subscribe to my channel and hit on the like button, and for notifications related to engineering drawing, you can click on the bell icon. You'll get all the notifications related to the video engineering graphics, or you can say the computer aided engineering drawing. Okay, now complete the arc. Okay, now here the length we should be drawing, that is the visible part of that funnel, that is 29 mm we need to mark. Okay, guys, this is my 700th video, so thank you for your support, so that I can grow my channel. I wish my channel may reach 1 lakh subscriber by another 2 or within 2 to 3 years. I hope so. Can cut the length, that is 29 mm. Okay, so okay, this length we should be darkening it. So I'll be using different color chalk here, sketch pen, so that you can make out the difference. Okay, this is the upper part of the funnel, right? That's why we need to show the lower part here in this development. Okay, guys, when you're going through my channel, if you're finding any difficulty in understanding, you can ask me your queries, doubts through comments, or you can mail me. I've given my email ID in the YouTube channel and my WhatsApp number also. So any doubts related to any of the videos, you can WhatsApp me or you can email me, so that I can help you. Okay, share these videos to your classmates and friends, so that they can be benefited. So guys, thank you all. Thank you for watching my video. So this is the development of the upper part of the funnel. Okay, so now you can see in this video both the things are done. So lower part of the cylinder also done and upper part of the funnel also done. Thank you guys. Thank you all. Thank you for watching my video.